In 2010, construction crews began boring through the Allegheny Mountains in Pennsylvania to carve a nearly straight path for a single fiber optic cable. The goal was to shave 3 milliseconds off the communication time between Chicago and New Jersey. This project was part of a larger global infrastructure expansion. Firms spent hundreds of millions of dollars laying dedicated high-speed cables across the floor of the Atlantic Ocean, specifically to serve high-frequency trading networks. This investment was driven by a specific assumption that in algorithmic trading, the first bot to react to a price change always wins. Financial firms effectively turned the market into a hardware race, spending billions to ensure data traveled as close to the physical speed of light as possible. However, despite reaching these near-light speeds, the profit margins for top high-frequency trading firms unexpectedly began to shrink. The industry had reached a physical limit. Shaving off more time was becoming astronomically expensive, and the returns on that investment were rapidly diminishing. This stagnation led researchers to shift their focus. Instead of asking how to build faster hardware, they began using machine learning to investigate if high-speed execution was actually the most profitable path. Researchers began exploring whether solving the problem of shrinking margins required a shift from the laws of physics to the logic of artificial intelligence. To test the actual value of speed, a study by Doss et al. Simulated a competitive limit order market. The researchers used a genetic algorithm, a framework that evolves trading strategies through millions of trial and error iterations, to find the most successful approach. The simulation tracked two specific metrics across every generation of trading bots: their raw execution speed and their final profitability. By monitoring the entire digital ecosystem, the study was able to plot the exact relationship between being fast and being profitable. This coordinate plane visualizes the results. The horizontal axis is speed, vertical is profitability. On the left, the line slopes upward. At lower speeds, being faster provides an information advantage, translating into higher profit. But at the highest speeds, on the far right, profitability collapses. This drop occurs because extreme speeds create hyper-competition. Algorithms cannibalize each other, destroying market liquidity and wiping out margins they race to capture. The maximum profit actually occurs at a moderate speed, creating a distinct hump shape in the data. The bots at this peak effectively trade away raw reaction time for a fraction of a second of computational overhead. That extra time allows for more complex analysis, which the simulation shows to be more valuable than pure speed. The AI simulation demonstrated that absolute speed can destroy value, while moderate speed, paired with computational intelligence, tends to maximize it. The quantitative arms race is shifting from hardware latency to cognitive strategy. Modern deep reinforcement learning models do not simply react to a price tick. They calculate the probabilities of various market outcomes before deciding whether to act. These agents can choose to leave capital uninvested as a risk buffer. They prioritize higher quality opportunities over high-speed, low-margin micro-trades. In this environment, the highest returns go to algorithms that can identify when it is most strategic to stay out of the market. This view of the New York Stock Exchange shows a market that was once defined by physical human chaos. Now, the most significant trading activity happens inside silent, strategic AI systems. The multi-billion-dollar obsession with achieving the absolute lowest possible latency was based on a flawed premise. The research suggests that an algorithm capable of adapting its strategy will systematically outperform one that relies purely on physical execution speed. Speed is only a measure of how quickly you reach the finish line. Intelligence determines if there is actually a prize waiting for you when you arrive.